Have you ever wondered how machines automatically maintain temperature, pressure, or speed? That's where control loops come in. Today, we are diving into open loop and closed loop control system, two fundamental concepts in instrumentation and control engineering. Let's get started. First, let's start with what is control loop. In simple terms, a control loop is a system used to regulate a process variable like temperature, pressure, or flow to keep it at a desired value. A control loop consists of four key components. First is process variable, the actual measurement like room temperature. Second is set point, the target value we want to maintain. Third is controller, compares process value with set point and takes action. And fourth is final control element, adjust the processes like opening a valve. Now let's explore the two main types of control loops. First one is open loop control system. First we have the open loop system. This system operates without feedback, meaning it doesn't check if the output is correct or not. Now let's check how it works. Step 1. The controller sends a command to the final control element. Step 2. The system runs its process without checking the actual output. Step 3. There's no automatic correction if something goes wrong. Let's take one example. Washing machines runs at a set cycle without checking if the clothes are clean or not. Second is electric kettle. Heats water for a fixed time without sensing the temperature. Now let's check main advantages of open loop system. They are simple and cost effective, easy to implement and works well for predictable tasks. Now let's check disadvantages of control loops. No feedback is equal to no automatic correction. Cannot handle unexpected changes and also less accurate than closed loop systems. Now let's take second part, closed loop control system. Closed loop systems are a more advanced and efficient system. Now let's check how it works. A sensor measures the process variable. Step 2. The controller compares PV with the set point. And step 3. If there's a difference, the controller adjusts the output. And step 4. The process continuously self-corrects based on the feedback. Now let's take one example. Air conditioner adjusts cooling based on room temperature. Second is cruise control car maintains the speed by adjusting the throttle. Industrial temperature control adjusts heater power to maintain the exact temperature. Now let's check main advantages of closed loop system. Highly accurate and adaptive. It is also automatically corrects error. Works well in dynamic industrial processes. Now let's go through disadvantages. More complex and expensive, requires continuous monitoring and sensors. Now let's check quick comparison between open loop versus closed loop side-by-side comparison. You can see that in the image. To summarize, open loop systems are great for simple predictive tasks, while closed loop systems are the best for precision and automatic correction. So next time when you see an automated processes, think about it whether it's a running in an open loop or closed loop. Which one do you use more in your industry? Comment below. If you like this video, don't forget to like, share and subscribe our YouTube channel. Thank you so much for watching. See you all in my next video.